Hey, what's up? Leetcode 3090, maximum length substring with two occurrences. Give it a string S, return the maximum length of a substring such that it contains at most two occurrences of each character. Output of 4. Okay. Contains at most two occurrences of each character. All right. Okay. So C equals, I guess, just default dict of int, right? And then J is going to be 0. And then we will say, wow, J is, well, max length is, it's always going to be minimum of 2. So J is less than length of S, right? And then we're going to need an I equals C. You know what? No. This is the wrong way to do this. For J in range length S, like that. So this will be the next to remove, right? And this will be the next to our current add, I guess. Current to add. All right. Yeah, that makes sense. 1, 2, 3, 4. I don't know why I didn't auto indent. I guess I got confused with the comment. Okay. So we are going to say C of J plus equals 1, and then while C of J is greater than 2, I plus equals 1. You know what? Let's do it like this. And then we will say C of S of I minus equals 1, like that, right? And then M equals max of J minus I plus what? J minus I. This means that we took 1 away. If we didn't take 1 away and we're at 0, then no, that's right. And the current max, and then return max like that. Oh my God. Yeah, sorry. Whoopsie. Whoopsie daisy. All right, unsupported operand. Oh my God, I hate you so much. J, comma, I don't know, CH in enumerate S. CH, J. Are you happy now? For hell's sake. All right, okay. Pretty good. Pretty good. All right, let's see if there's any easies that I have not done. Type algorithm status to do. And also difficulty is easy. Oh shit. I guess there's a few. Okay. Unique middle element. You're given an integer array nums of odd length. Return true if the middle element of nums appears exactly once in the array. Otherwise, return false. Oh boy. C equals counter of nums if C of nums of length, nums, let's see if it's length, just like that. If it's 3, then yeah. Because 1 would be 0, and then 3 would be 1, yeah. All right. Sum of integers with maximum digit range. That does not sound like an easy question, but let's see. You're given an integer array nums. The digit range of an integer is defined as the difference between its largest digit and its smallest digit. Okay, it's starting to sound like it easy now. For example, the digit range of 5724 is 7 minus 2 equals 5. Return the sum of all integers in nums whose digit range is equal to the maximum digit range among all integers in the array. And how big is it? All right. Okay. So, yeah, it's always at least length 2. So we're going to say def digit range of I is x equals max str of I, y equals min of str of I, right? And then return ORD of x minus ORD of y. Then we want to know what the max is. So max digit range equals max of digit range of I for I in nums. And then it just wants to know how many there are. Hold on. Nums of I. Return the sum of all integers whose okay, I got confused for a second. Return sum of I for I in nums if max digit range equals digit range of I. All right. Rearrange string to avoid character pair. You're given a string S and 2 distinct lowercase English digits X and Y. Rearrange the characters of S to construct a new string T such that T is a permutation of S. Every occurrence of Y appears before every occurrence of X in T. Return any valid string T. Okay, so permutation and every occurrence of C appears before every occurrence of A. All right, okay. G equals, well, now we don't need to do that. Yeah, we do. G equals S dot replace X with nothing, right? And then count of X equals length S minus length G. And then G equals G dot replace. That's not going to work. Let's see here. Of Y. And then this is going to be G is the longer one, G2 is the shorter one, and this is the count of Y. Okay, now we want to return whatever's left. All right, let me see. So every occurrence of C, okay, every occurrence of Y times count of Y occurs before every occurrence of X times count of X, right? Hey, that one was kind of fun. All right, really? Is that slow? Maybe the replace operations were not ideal. Yeah. Let's say C equals counter of S. This is probably better. And then CY equals C of Y, right? And then CX equals C of X. And then C of Y equals 0 and C of X equals 0. Actually, let's do this. And then if not C, then return. If not CY or not CX, then simply return S, right? And we can do that before the division operation. That'll speed it up. Now, if not C, then that means that there is nothing left here. Now, otherwise, we have to construct whatever is left, which we can do. Character times I for I comp. That's not how that works. In C items. Okay, is that right? That's even slower? What are people doing that's so much faster? Well, now it's starting to piss me off. Okay. Okay, now you're kind of making me angry here. So S list equals list of S. Okay, if I don't get a speed improvement, it's 4 milliseconds. It's 4 milliseconds. Okay, maybe I am kind of being dumb here. All right, whatever. Let's say I comma j equals 0 comma 0. Is that what we want to do? Yeah, I think, well, j equals 1, I guess. So j has to be bigger. That doesn't even make sense. J equals length of S minus 1. Yeah, I think, yeah, that's what I meant to do. Okay, now, while I is less than j, if SL of I equals X, then SL of I SL of J equals like that, right? And then J minus equals 1, else I plus equals 1. Right, and that should move them all to the beginning. And then we can just say return join SL. Okay. We were supposed to move the C's to the beginning. My original one should have been right. We moved all of the A's to the end, right? If SL of I equals X, no, that's desired. That is desired. Okay, it should be Y. Okay, so we should be moving all of the C's to the end, which we did. Oh my God, what? Now you're pissing me off. Okay. Every occurrence of, okay, appears before. So Y has to be before. And I put it to the end. Okay, so we need to be moving, but this doesn't make sense. It should work one way or the other, right? I should be able to move one to the end and fix it. This is so stupid. It's the same fucking thing. I'm typing the same thing. Okay, I probably just made a stupid mistake or something. So every occurrence of Y has to be moved to the beginning, right? So if SL of J is equal to Y, then we need to move it to the beginning. In that case, SL of J, comma, SL of I equals like that, and then we're going to look at the next lower one. No, we do not look at the next lower one. We advance I. We only look at the next lower one if it wasn't, because we might have moved something that we weren't supposed to. That's the reason. Then when they cross, we're done. Oh, boy. Wow. Maybe I should stop doing Leetcode. See, SL of J should be triggering here. J, oh my God. J, there we go, there we go, there we go. That was the problem. Did I do that the first time? Is that why my first solution wasn't working? Okay, beats 100%. Screw that problem. Okay. Leetcode 4006, count valid prefixes. You're given a binary string S. A prefix of S is considered valid if its characters can be rearranged to form an alternating string. Return the number of valid prefixes of S. Okay, so there can be at most one more than the other, right? In other words, the difference between the two is at most one. Count 0, count 1 equal, don't do it like that. C equals 0, comma 0. For I in S, C of int I plus equals 1. And then we want to know if that's a valid. Well, now hold on. It says valid prefix. Okay, so it's not a valid substring. Sorry, I was about to make it harder than it needed to be. That probably would have been the medium version of the problem. Okay, so just a prefix. I had it right. CNT equals 0. If CNT of 0 minus CNT of 1 is less than or equal to 1, and -1 is less than or equal to it. Is there an exception? No, there's not. Okay. Then in that case, CNT plus equals 1 and returns CNT. Int object is not subscriptable. All right. Again with the bullshit. Okay, whatever. Maximize pair strength using greatest common denominator. Hold on. ORD. Okay, that's a little better. Maximum pair strength using greatest common denominator. You're given an integer array nums. Choose exactly one pair of distinct indices ij. The strength of that pair is defined as nums I times nums j divided by the greatest common denominator of nums I and nums j. Return the maximum strength over all possible pairs. So just brute force. Do they really expect me to recreate Euler's formula? Can I use the built-in greatest common denominator? Return the maximum strength over all possible pairs. All right, for I in range, length nums. Is there anything that's order dependent? No, there is not. So J, not H, J in range, I plus 1 to length nums, and then strength, we'll say max is -1. Strength equals this bullshit. That's squared. Oh, for hell's sake, you can't copy it. Okay, nums I times nums j. Is there like some trick to this? Divided by the greatest common denominator of nums I, nums j. Why do I feel like there's a trick here? Well, it's squared though. It's squared. It's supposed to be... In all of these examples, they're even. Returns int. Okay. Well, if it's the greatest common denominator of both of them, then yeah, you would be able to square it and divide it evenly. Okay, that's right. Okay, m equals max m comma st, return m. It'd be much harder if you had to calculate the greatest common denominator. It's possible, but... Okay, now I'm curious, though, is... You're removing the similar factors from each of these, right? Because the greatest common denominator is what's in both of them. And so it's almost like non-shared primes are what are going to be returned. Do I want to make a sieve? I could. See if I could speed it up a little. Okay, so you receive a list. Maximize pair strength using greatest common denominator. It's almost like you could use the counter of the primes that are in there, then just subtract one from the other, and then multiply those together. That would be pretty trivial. But would it be more fun? Would it be more fun? Okay. I'm overthinking it. If I ever get I think that would be pretty easy to do if I ever receive a harder problem like this, but I'm not going to mess around with it for an easy. So, all right, see ya.